They carry tiny hammers, they're chipping at the crust. Like a John Fontaine novel, they're inclined to ask the dust. Converging on the continents, they're fearless and they're brave. They're cruising down through canyons and exploring every cave.
This is our first specimen, which primarily consists of hornblende. You can see with the dark color, and hornblende over here as well as diopside running down the middle. We've got some good cleavage. You can see clearly the shine going on right here on both sides. And then we have a good cleavage on the back here as well. I bet you're taking notes right now because hornblende has cleavages at 120 and 60 degrees.
So many beds, so little time.
In our second specimen, you can see that in the middle here we have diopside, and over here we have a combination of marble and some amphibole. And if we put the hydrochloric acid, you can see it effervesce. I swear it does more than that. But on the other side we have amphiboles.
Here we have samples 3 and samples 7 of carbonatite. If you look, it's a calcite matrix with fluorictorite crystals. Fluorictorite is a type of hornblende, and it has the same hardness, except the difference is the OH has been replaced by fluorine. Now if you look at it, it looks a lot like a cookies and cream Hershey bar. So it's a lot of fun to hand these out at Halloween. The parents aren't too impressed though. And let's look with some acid. Oh, look at it go, look at it go. There it is.
Men are all the same.
Rockhammer fight.
The next sample we have here is a sample of diopside. You can tell by its greenish color, and this is one of my favorite. That had better not be an electronic widget.
Okay, so here we have a sample of calcite, and there are two ways that you can tell that this is calcite. One, you can see the rhombohedral cleavage, which you can see like right here and over here. And two, the other thing that you can tell is by putting a little bit of hydrochloric acid on it, which should make it effervesce. I swear it's doing it. Really.
So here's
Really?
sample 6. It was found on the other side of the road, and when we looked at it again a couple months later, to be honest, we couldn't figure out what it was. Some of us weren't taking notes in the field, apparently. So we thought it was quartzite at first, but when you put some acid on it, lo and behold, it effervesces. Isn't that magical?
May the quartz be with you.
It was effervescing because there was carbonate in it. So that means it has to be diopside marble. There's also some green stuff.
I'm too sexy for my shirt.
The green stuff is diopside.
So this is sample 8 that we've collected from our site, and the composition of this sample is mainly some calcite, which is this white stuff, and the black stuff is biotite. And on a good day, it does flake off. You're gonna have to take my word for that. And to prove that the white stuff was calcite, we're gonna be using some hydrochloric acid, and it effervesces like crazy. And now to get in more specifically to see the cleavage, we're going to need to go in a bit further. And that should show it. As a professional rock detective, mystery solved.
I'm in a hard rock.
These are an extra little treat. They're fluorictorite crystals that we found at the site. And according to rockhound.com, they're worth approximately $100. So Jen, if you want to talk to one of our Not Our Fault associates after the class, we can get an estimate for you on these ones.
This concludes our explosive presentation.
Happy retirement!